Welcome to this presentation on Python inheritance, a key concept in object-oriented programming. In this module, we'll cover single inheritance, where one child class inherits from one parent class. We'll also explore multiple inheritance, where one child class inherits from multiple parent classes. Lastly, we'll discuss multilevel inheritance, where child classes inherit from classes that themselves inherit from other classes. Let's dive in. Let's start by understanding what inheritance is all about. Inheritance is a mechanism where a new class, often referred to as the child class, can inherit attributes and methods from an existing class, known as the parent class. Inheritance promotes code reusability, allowing you to use existing code as the base for your new class. It establishes what we call an is a relationship between classes, meaning a child class is a specialized version of its parent. Inheritance also allows for the extension of existing functionality by adding new methods and attributes to the child class, and it facilitates method overriding, allowing a child class to provide a specific implementation for a method already defined in its parent class. Now let's talk about single inheritance. Single inheritance occurs when a class inherits from only one parent class. Here's an example. We have a class called animal. It has a constructor that takes species as an argument. It also has a method called makeSound, which currently does nothing. Then we define another class called dog, and in parenthesis we pass animal class. This means the dog class inherits from the animal class. In the dog class constructor, we call the parent class constructor using the super function, passing it the string canine to set the species. We also set the name attribute for the dog class. Finally, we override the makeSound method to return the string woof. Notice that the dog class automatically inherits the species attribute from the animal class, and we can also customize or extend the dog class by adding new attributes like name, or modifying existing methods like makeSound. Let's look at a more detailed example of single inheritance. Here we have a class called vehicle with attributes name and color, and a method getInfo that returns a string describing the vehicle. Then we have a class called car that inherits from vehicle. The car class has its own constructor which takes name, color, and model. Inside, we call the constructor of the vehicle class with super and pass name and color. This way we are reusing the code in the vehicle class. The car class also has its own method called getCarDetails, that calls the getInfo method from the vehicle class using super, and then adds the car's model to the string. When we create an instance of the car class with the name Tesla, color red, and model S, we can call both getInfo, which is inherited from the vehicle class, and getCarDetails, which is defined in the car class. The first output is vehicle Tesla, color red, which comes from the vehicle class. The second output is vehicle Tesla, color red model S, where the initial part comes from the vehicle class, and the last part comes from the car class. Next, let's delve into multiple inheritance. Multiple inheritance is when a class inherits from more than one parent class, combining attributes and methods from all parent classes. This means a child class can inherit from two or more parent classes. It's useful for combining functionality from different sources. However, it can also lead to the diamond problem, when method resolution becomes ambiguous. Let me explain the diamond problem a little bit. Imagine a class D inherits from class B and class C, and both B and C inherit from A. Now, if D calls a method defined in A, which version of the method should D use? The one inherited through B or C? Python uses something called method resolution order, or MRO, to determine which method to call in situations like these. Here's an example of multiple inheritance. Let's define a class called flyable. The flyable class has a constructor that takes wings type, and a method fly that returns a string saying that it's flying with whatever wing type it has. Next, we define a class called swimmable, with a constructor that takes fins type, and a method swim that returns a string saying that it's swimming with whatever fins type it has. Now we create a class called flying fish. It inherits from both flyable and swimmable. The constructor takes name, wings type, and fins type. Inside, we call the constructor of both flyable and swimmable, and we also set the name for the fish. We then create a method called describe, and it returns a string saying that the fish can both fly and swim. When we create an instance of the flying fish class called Pacific Flying Fish with wings type as pectoral and fins type as caudal, we can call the fly method, the swim method, and the describe method. These methods return the following strings respectively: flying with pectoral wings, swimming with caudal fins, and Pacific flying fish can both fly and swim. Now let's discuss the method resolution order, or MRO. MRO determines the sequence in which Python looks for methods in a hierarchy of classes with multiple inheritance. In other words, it's the order in which Python searches for a method in a class hierarchy. Here's how you can check the MRO of a class. First, we define three simple classes A, B, and C. Class C inherits from both Class A and Class B. Now, if you want to see the MRO of Class C, you can print c.__MRO___. The output tells us the order in which Python will look for methods if they are called on an instance of Class C. Python first looks in Class C, then Class A, then Class B, and finally in the base object class. Now let's come back to the diamond problem. When a class inherits from two classes that both inherit from the same base class, which version of the base class method should be called? MRO helps resolve this ambiguity by providing a clear and predictable order in which methods are searched. Finally, let's explore multilevel inheritance. Multilevel inheritance occurs when a class inherits from a child class, creating a parent, child, and grandchild relationship. In other words, it forms a chain of inheritance. Each derived class inherits features from its immediate parent and all its ancestors. This allows for the creation of specialized hierarchies. However, it can become quite complex with deep hierarchies. In this diagram, the grandparent class is at level 1, the parent class is at level 2, and the child class is at level 3. The child class inherits from the parent class, which in turn inherits from the grandparent class. This creates a chain where the child class has access to attributes and methods from both the parent and the grandparent classes. Let's see an example of multilevel inheritance. First, we define a class called animal. It has a constructor that sets alive to true, and it has a method called breathe that returns a string saying breathing. Next, we create another class called mammal that inherits from the animal class. It calls the parent constructor and sets warm_blooded to true, and has a method called feedyoung that returns the string feeding with milk. Finally, we define a class called cat that inherits from the mammal class. It calls the parent constructor and takes a name, then also defines a method purr that returns the string purr, and it defines another method called getInfo that returns a string with the cat's name and whether it is alive and warm-blooded. Now, when we create an instance of cat class with the name Whiskers, we can call the breathe method from the animal class, the feedyoung method from the mammal class, and the purr and getInfo methods from the cat class. They return the following strings respectively: breathing, feeding with milk, purr, and Whiskers is alive, true, warm-blooded, true. To finish up, let's review some best practices for using inheritance effectively. First, the do's. Use inheritance for is a relationships. Keep inheritance hierarchies shallow. Always use super to call parent methods. Favor composition over complex inheritance, and document class hierarchies clearly. On the other hand, the don'ts. Don't create deep inheritance chains. Avoid inheritance for has a relationships. Don't override methods without calling super when needed. Avoid complex multiple inheritance structures, and don't depend on implementation details of parent classes. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.